Alright, let's try B-4 again. I did this in class, but I kind of want to redo it so that you guys can see how I did it. Um, and you can pause if you need to write something down, or if you don't understand something, you can take a little longer to look at it. Okay, so okay, we have a guy. He's gonna throw. Okay, he runs to the open window and throws his red marking pin into the air with an initial upward speed of 5 meters per second. So VI is 5 meters per second. A. If the window is 12 meters above the ground, what is the velocity of the pin 1 second after it is thrown? So time equals 1 second. Alright. We know acceleration. He's throwing the pin up. That's positive. So the acceleration due to gravity is down, and so that's going to be negative if we're saying this is positive. So I'm going to use 10 in this problem. Alright, we have 3 of the 4 unknowns, so let's go ahead and just plug into an equation, and if we do, we want to know VF, right? A, what is the velocity of the pin after, so VF, that's what we're looking for in A. Alright, so the equation I could use is one with acceleration time, VI and VF. Oh, what if we use this? VF minus VI over T. Alright, let's just plug in here. Acceleration is negative 10. VF, we don't know. Minus VI, 5. 5 by time, which is 1 second. Alright, 1 times negative 10 is negative 10, so we have negative 10 equals VF minus 5. I'm going to add 5 to both sides. And we're going to end up with a negative 5 meters per second, because it's speed, it's velocity. Okay, and that negative 5 just means it went up, and now it's coming back down at negative 5 meters per second, so it's going down now. And it's actually, if you remember our problems, we can, in our brains, cut this in half here, what this pen is doing. It's going up, it's going to take so much time to go up, and then it's going to take the exact same amount of time to go down, even with his hand where he released the pen. And so it makes sense if the VI is 5, the VF over here, even with the hand, is negative 5 as well. Okay, so that's A. We know the speed that it's going after 1 second. It's going back down. We can go to B here. How far has the pen fallen from its starting position after 2 seconds? So, go here, extend page. Let's go, this is B. So time in this case is 2 seconds. The VI was 5 meters per second. It was thrown up, right? Acceleration, since this is going up, the acceleration is negative 10 meters per second squared. And we're looking for how far, so the distance. All right. Well, we can use D equals VIT plus 1/2 AT squared. All right. So let's just plug in the numbers. We have 5 here, 2 here, plus 1/2. Acceleration is negative 10. Time is 2 squared. So let's do this here. This 5 times 2 is 10. This should have 3 sig figs there. 1/2 times negative 10 times 2. Okay, so that's 4 times 10, negative 40, divided by 2, negative 20. This is the distance. Extend page a little bit more. 10 minus 20 is, and this should be, if looking at sig figs, that brings that to 2 sig figs. because that has 2, so our answer here should have 2. 1 decimal place, or 2 ones place here, to the 10th, so our answer should be to the ones place. So we have negative 10 of a decimal meters. And that means that it has fallen after 2 seconds. If we say this is at the 0 mark where he throws his pin, it goes up, and then now it's at negative 10 meters. So negative 10 meters from the 0 mark is down about here. So that's where the pin's at. It has fallen negative 10 meters after going up a bit. So that is B. Make that negative sign more. That is the distance. All right. Let's try to do C now. Actually, I'll make another video for C. Let me pause this.